Hello, honors pre-calculus students. Today's learning target is to talk about arithmetic sequences. So in class, we developed the formula that an is equal to a0 plus d times n. And we discussed that arithmetic sequences are like linear functions. D is called the common difference, which can be found by doing a2 minus a1. Or you could use a3 minus a2. And then a sub 0 is sort of like the y-intercept. We also discussed the textbook formula that a sub n is a1 plus d times n minus 1. So if we look at problem number 1, I'm going to find the common difference here by looking at the difference between consecutive terms. So doing that, I find that the common difference is 10. If I wanted to use the red formula on the right, I need to find the number in front of the negative 10. So a0 would be equal to negative 27. So the explicit formula is a sub n is negative 27 plus 10n. If you want to use the blue formula, I'm going to write down the blue formula. If I substitute in the numbers, negative 17 plus 10 times n minus 1, and if I distribute negative 17 plus 10n minus 10, notice you're going to get the same formula, negative 27 plus 10n. Now the goal was to find a sub 98, so a sub 98 is negative 27 plus 10 times 98, and using my calculator and plugging that in, I'm going to get 953. If you look at problem number 2, we want to know how many terms there are. First step, I need to find the explicit formula. So I'm going to use a0 plus d times n. Here the common difference we can see is equal to negative 20. So you're always subtracting 20. And if you were to go backwards and find the term in front of the 10, it would be 30. So the explicit formula is 30 minus 20n. Since I want to know how many terms, I'm going to set the negative 1710 equal to 30 minus 20n. Doing a little algebra, you'll get negative 1740 is negative 20n. Dividing, you get n is 87. So there are 87 terms. In problem number 3, we want to find the value of x and then the common difference if these are arithmetic. So earlier, the common difference we discussed was a2 minus a1, or you could say a3 minus a2. So here we have a1, a2, a3. So what that means is 20x plus 1275, that's a2, minus a1, make sure you include parentheses, is equal to a3, 4x plus 209, minus a2, again, make sure you include parentheses. I'll leave that as an exercise for you. If you distribute properly, you will get x to be equal to negative 66. Then if I plug in negative 66 into a1, which is the x plus 31, the first term will be negative 35. If I plug negative 66 into a2, which I just highlighted in green, you will get negative 45. And if you plug x into a3, which I just highlighted in pink, you will get negative 55. So if you're looking for the common difference, you are always subtracting 10. If you take a look at problem number 4, there are multiple ways of doing this problem. If we remember that linear functions, so a sub n is equal to A0 plus dn, that's similar to if we look at problem number 4, there are a couple of ways of doing this. If we remember, linear functions y equal mx plus b are similar to arithmetic sequences a0 plus dn. So if you were to match these up, d is like the slope and b is like the y-intercept, or b is the y-intercept. In problem number 4, we want to find the explicit formula an equals a0 plus dn. Remember, arithmetic sequences are like linear functions, mx plus b, where the slope is like the common difference and b is like the y-intercept. So looking at this problem, I could think of this green highlighted as a point. So I could think of that as 12, 172. I also could think of the 56th term as a point, 56, 876. So the first step is I'm going to find the common difference, which we called slope when we did linear functions. So doing the math, 876 minus 172 over 56, take away 12. You'll get the common difference to be 16. And we know the explicit formula is A0 plus D times N. So this is like now plugging in a point. I'm going to use this yellow highlighted point. So I'm going to say 172 is equal to A0 plus the common difference, 16, times N, which is 12. Doing a little arithmetic. So 172 is equal to A0 plus, I believe that number is 192. So when I subtract 192, I get negative 20. So the explicit formula is an equals negative 20 plus 16n. In problem number 5, we want to find 4 arithmetic means between negative 40 and negative 96. What that means is I have negative 40, I'll call that A1, then I have A2, A3, A4, I want 4 values, so A5, and then negative 96. So when I say I want 4 arithmetic means between these values, that means I need to have 4 numbers here between those, and this is a arithmetic sequence. So remember, this is A1 and this is A6. So again, I'm going to find the common difference. That's like slope. So negative 96, take away 40, take away negative 40, over 6 minus 1. Doing that on my calculator, so negative 96 plus 40 and divide by 5, we'll get the common difference to be equal to negative 11.2. So to find the 4 arithmetic means, I would start with negative 40. I would subtract 11.2. So the next term is negative 51.2. Subtract another 11.2, so you get negative 62.4. Do that again, you get negative 73.6. One more time, you're going to get negative 84.8. And just to check it, I'm going to subtract again, and I do get negative 96. So the 4 arithmetic numbers between those would just be these values that I'm writing down. This problem is related to the next unit, so I'm going to save this problem for another time. We did do it in class.